Hello everyone. In this video we are going to explain about one of the well-known expert system, MYCIN. So first of all, let's see what is expert system.
Expert systems are one of the prominent research domains of the AI. It is introduced by the researchers at Stanford University Computer Science Department. Now, what are the expert systems? The expert systems are the computer application developed to solve complex problems in the particular domain at the level of extraordinary human intelligence and expertise. Here are some of the characteristics of the expert system, that is, high performance, understandable, reliable, highly responsive, and there are some capabilities of the expert systems, that is, instructing, assisting human in the decision making, demonstrating, deriving a solution, diagnosing, explaining, interpreting the input, predicting the result on the basis of the input, and justifying this conclusion on the basis of it, and suggesting some alternative options to the problem. But there are some things which it is not incapable of, that is substituting human decision makers, possessing human capabilities, or refining their own knowledge. Now, MYCIN. MYCIN was an early expert system developed over 5 or 6 years in the early 70s at Stanford University. MYCIN was never actually used in the practice. This wasn't because any weakness in its performance, but actually it was as much because of the ethical and legal issues related to use of the computer in the medicine. If it gives the wrong diagnosis, who can be held responsible? And the MYCIN was early backward chaining expert system that used artificial intelligence to identify the bacteria causing several infections. Actually, the program ran on the large shared system available over early internet before personal computers were developed. As you can see the architecture of the MYCIN, there are some of the components you can see there, that are knowledge base, human expert, knowledge engineer, inference engine, user interface, and finally a user.
We will explore the knowledge base of the MYCIN expert system. The knowledge base consists of information in the form of facts. These facts or knowledge are provided by the domain experts. In case of MYCIN, the domain experts are doctors who have their specialization in blood-related infectious diseases. This information collected from domain experts is converted into facts by knowledge engineers, which is then stored into the knowledge base. The knowledge base consists of 3 types of knowledge. First is the inferential knowledge. As the name suggests, this knowledge is used by the Inference Engine to take decisions about the advice that has to be given to the user in response to a query. Next is the static knowledge. The static knowledge is prefed into the system and remains constant during the lifetime of the system. Third is the dynamic knowledge. It is stored in the form of context trees. This knowledge is obtained by the system at runtime. It basically consists of patient-related information which cannot be prefed into the expert system. Let's explore these concepts a bit further. First is inferential knowledge. It consists of if premise then action rules. These rules are simply if-else conditions, wherein if the premise or certain set of statements is true, then the system can determine that the patient has a particular disease with a certainty factor. The certainty factor is basically probability of confidence by the system for a particular infectious disease. Next is static knowledge. The static knowledge consists of lists and tables, which are basically a combination of medical terms related for every infectious disease. Next is the dynamic knowledge. The dynamic knowledge is patient-specific knowledge. It consists of hierarchical structures which allow us to organize the information related to the patients and also to the cultures and organisms which have been observed in their blood samples. Now, the knowledge base uses 2 types of data structures, static and dynamic data structures. The static data structures consist of list, knowledge tables, and classification systems. The lists are used to enumerate the different organisms that the expert system recognizes. The knowledge table contains clinical parameter values for various infectious diseases under various circumstances. Classification system can apply these clinical parameters under various contexts. Next is the dynamic data structures. Context trees are used for the dynamic data structures in the knowledge base. They are also known as variable length Markov chains because they are Markov chains whose length depends on the past symbols. They are used to organize information related to a particular patient. Since we can give it a tree-like structure, it can be used to correlate or structure a clinical problem and relate multiple contexts with each other.
Now let's see what is Inference Engine. So before going to the Inference Engine of MYCIN, let's see what is Inference Engine in general. In case of knowledge-based expert system, Inference Engine arrives at a particular solution by manipulating the knowledge from knowledge base. To arrive at a particular solution, Inference Engine uses two strategies: forward chaining and backward chaining. In forward chaining, based on facts and rules, Inference Engine arrives at a particular solution or conclusion, whereas in backward chaining, based on current solution or conclusion, it tries to acquire the responsible rules and facts for that result. Inference Engine in MYCIN uses backward chaining. In this, based on conclusion, it tries to find the rules that gives this conclusion. Means we know that the person has certain infections, and based on that infection, Inference Engine tries to find the causes for that infection using the rules and facts present in the knowledge base. Now let's understand the inference strategy of Inference Engine. So first of all, Inference Engine attempts to establish values of clinical parameters at the leaf node. Then, based on the current goals, interpreter retrieves list of rules which are responsible for these goals and evaluate those rules. It will ask questions to the users if rules are insufficient to reduce the necessary information. And if user won't be able to supply the information, rule will be ignored.
Hi, so let's start with user interface. Before going to user interface of MYCIN, let's know more about user interface in expert systems. User interface provides a means of interaction between expert system user and expert system. It's generally natural language processing so as to be used by other user who is well versed in task domain. The user of expert system need not be necessarily an expert in artificial intelligence. Requirements of efficient expert system user interface. It should help users to accomplish their task goals in shortest possible way. It should be designed to work for users' existing or desired work practices. Its technology should be adaptable to users' requirement, not the other way around. It should make efficient use of user input. So now let's move to MYCIN user interface. MYCIN provides us command line interface. To install MYCIN, we need to follow these steps. First, we need to install Ruby. Now download MYCIN RB and test MYCIN RB from the link provided in description. Now let's start with executing command ruby test mycin.rb. MYCIN asks questions, reasons, gives explanations on why it is asked the questions and deals with uncertainties. Here, as you can see in example that user can anytime write help to get the information about what to do next. User can also write why to get the reason why MYCIN is asking such questions. Here, as you can see, after the questionnaire is over, MYCIN provides its findings with confidence factor and asks if there is another organism. If yes, the questionnaire starts again.